Hello, welcome once again to the part 2 of the two-floor duplex you must start with as a beginner. In this section, we are going to look at the various analysis, how we are going to run the analysis in our model, and we're going to look at the basic foundation, how we're going to select our material. We're going to look at the foundation, look at pad foundation. So we're going to look at how we're going to set our pad foundation in this section. So my name is Adasi Yunel and I'm your instructor. So what do we do? Quickly, a quick one. We're going to go to our member, our analysis. Click on analysis, go to building analysis. You wait for it to load. It's going to save and it's going to take you back to a pop, bubble launcher. So we're going to look at this. Look at this interface. You can see all the code referencing for all the design. So what we're going to do, the first approach, what we're going to do here is to look at our material. You can see these are the material that it comes default. You can see, but you can go back and edit to your own material, to the suitable material you want, the suitable steel grade, the concrete grade that you want to use in designing the loads and the sizes of the bar that you want to use in designing the structure. You have to go back and design. So for you to go there to specify or pick those points, what you need to do is to click on edit material. So you click on edit material, as simple as this. So clicking on edit material, you can see the default material and the foundation material. So this foundation material talks more about the soil link and all more about the foundation. So we're going to the material. The material talks more about the columns, the slabs, the ridge slabs, and other members. So in this regard, we're going to focus more on our columns, the beam, the slab, and every other element that we are, using to execute this, model. So we'll click on this. We want this to be our, we'll click on this. So we're going to take this and apply them to all material. I want to use this concrete grade of 20 and the cylinder cube of 25 to use it to apply to all specification. So it should be the same for everything I'm designing. So the same thing here. I think I'm okay with this grade. I'm okay with the 450 strength, depending on where your location and the strength of the steel you have, the reinforcement material you have. I think this is okay. This 410 is what I'll be using to design this model. So doing this, you go to the column, the concrete column. So what do we do here? You highlight the bubble for the column. Now, look at the size of the bar. These are the level telling you various sizes of the bar, the 16, the Y16, and all of them. These are all sizes. The 16 mm, the 7 mm, the 10 mm, the 12, the 20, and on and on and on and so forth. So this other one is the diameter, still referencing the same thing. Where you have the Y13 is still 13 referencing it, and this is your hook length and the area of the reinforcement, the area of the reinforcement. So what you're going to do, you're going to pick the one you want to use to design your column, because these are column rear bars you're providing. So providing column rear bar, I advise that you use your 16, 20, and 25. So untick every other box apart from the 16, 20, and 25. So we can untick. For the purpose of this design, I'm going to untick 32. And secondly, you have to look at the provision for the material, because when you're designing, you should also look at the structure you are doing. Let's say you're having a simple structure, for example, or let's say you're having a simple structure, for example. You're going to look what would be the recommended based on cost, what I'm going to have on the market that will be sufficient for your reinforcement. But in that regard, if you're still doing some maximum, you're doing a higher, kind of job, a versatile job, big job, something like that. So when you have such massive, I think you should put cost away and aside. So you have to untick this and to also look at some other reinforcement that you know can be due and suit your own environment. So for the purpose of this design, I'll be picking the 16, the 20, and the 25. So I'm not going to click apply to all members because I want to pick them each one after the other, you know. So I'm not designing a wall, so I'm not looking at that. So what I'm going to go, the next one is the beam. So I'm going to take the rebar for the beam. And for the beam, we're going to go the same. We're going to take 16, 20, and 25 to design our beam. But in this regard, I don't want 25 to use 25 mm to regard because it's a simple structure. So I'm going to untick this. I'm going to use only 16 and 20, So if you're still looking for cost, you can still include the 12 mm depending on the bar size. So for the purpose of this video, we'll go with 16 and 20 for our beams. You can see for your beams. So we're going to click OK. And on the slab, I'm going to untick all except my 12 mm. I want to use the 12 mm in detailing the slab because of the simple structure I'm having. So in this regard, I'm going to click OK. So that is that. So for the link, you're going to click the link. For the link, I'm going to use 10 and 8 mm for the link. So I'm going to untick every other reinforcement except the 10 and we're going to check if there's anyone that's active. So we're going to go with 10 and the 8 mm. Anyone press far. You can decide to choose one, you can decide to choose the other one. Anyone you choose is best fit. But when you're giving both options, you are telling him to use the minimum. If the minimum is not sufficient, he can now use the other one. So in that regard, we can say okay. So we've done this. We are not designing the steel columns and some other ones. So we're going to neglect this. We are not designing all this horizontal web. So we're going to leave that. We're going to go back to our foundation floor. So the foundation floor, we're having the same concrete grade, on the sand. We're going to design that when we're talking about our foundation design. So we're going to leave the specification for the sand right now. So we're going to the link. So the link, you still bear the same thing. So it's still okay. So at this point, we're going to say okay. So clicking on OK, you go back to your analysis. So in your analysis, you untick this, selecting all the material, and it says still member design check. We untick that so I can run our steel design and check all the steel reference. So we can tick this so they can select bar. We don't need to do our batch again. So you taking this is going to do your batch design if you're considering your interactive design. That's the more reason why you need to click this and make sure everything is okay. So after ticking this, we can now start launcher and start running the analysis. You can see start running. So you wait on for a while and see where you select. So it's going to run your beam and column batching. So you're going to wait on for a while the analysis is going to take a few seconds while you run the analysis. And you look at various taking all the impact, taking all insufficient, and so just hold on for a while for it to finish the more analysis. You can see pop-up said column sufficient, axial load table, and everything, and you said okay. So the analysis is run successfully, and you can see beam reinforcement design is completed. So all the analysis is run successfully here. So what we're going to do now is we're going to check the analysis, check the impact of the structure, and the result of gut. So what you're going to do is to click this button here, say close, because we're done with analysis. So closing, here we are on the plan again. So what we're going to do to check what we've done so far is to go to our visual setting. So if you go back to visual setting, click on the You click on the video setting, you know, so you scroll down on the video setting, you're going to see where you have design. You can see the section material, you can see loads, and you see your design. Click on design status where you have design as design status, still design, utility ratio. We're going to look at the design status. So if you click on design status, it's going to show you the design status of the building. So you can click OK. So you can see that all the members are on green. So you can see a tree here, a key showing you the design status. The red means fail, yellow means warning, and if you have this, your amber color means you have an expired analysis. Maybe you've altered some changes in the analysis. Maybe you ran the analysis and analysis either it passed or it fails, and you automatically change, do some change, terminate the analysis process. So such design has been expired. You're going to see from your design status, you're going to see such color. When you have a green all through, it means that that design is successful. Not design is white color, do not design. That's in a worst case scenario. So in this, you check other floors. Let's say this is our second floor and our third floor. Consider everything we design here is successfully and has passed successfully. With this design, you're sure and rest assured that you've done a great job by modeling a two-story building with a great impact, with your arms on your chest that this is a good structural analysis. So it's a good one. So we can still go back to you know our visual option, the design, and you say none. Just go back to it and say none. So it can go back to you know your plan view. So you can see from now you know that you've run all your analysis is successful and everything has run okay, your design is okay. You can now send it back to the detailed template where you can furtherly make some a detailing, and you can make it presentable. You can add a template to it, add the names of the client and every and as well as you to providing the result and the analysis for all this job that you've pretty done. I hope this helped. So keep in touch. I should take you on the next move. So the next move here, we're going to take, or we're going to go on the detailing template. So we're going to move this to the other software. So right now our design and our model is okay. So in doing this, it is very, very simple. We can now go to our foundation. We can go to our foundation design. So in doing your foundation design, we are assuming that the soil is okay. So we'll click on story 00. So story 00 will only show us our column. So since the foundation is suitable, we are going to be designing with a pad foundation. So we right click. For you to add your footing, your pad foundation, what do? You come on your column, you click the column, you left click, and you right click. Right clicking on the column, you see edit section, parameters and all that, materials, edit materials, measurement. We're not going to do that. We're going to click on the insert pad base. So if you click on insert pad base, it's going to give you a box. So this is where you insert the formations of the base. This is where you include the formations of the base. You have to construct the soil, do the soil test and have a good one. Let's assume that we are having a bearing capacity of soil. Our soil stress is, let's assume our soil stress is 150 kilonewton per meter square. So we're going to do this. Our concrete cover, we're going to allow our concrete cover to be 50 or 40 as the case may be. Let's allow it to be 40 on site. You can consider using 50. But for the purpose of this design, we'll use 40. So what will be the depth of our foundation? So the depth of your foundation, let's use 150. So we'll have a sufficient depth for our foundation. So We're going to include the footing depth. We're going to look at our soil strength by checking the soil. I'm going to check on, the bars we are going to use. So let's use 13 because this the software did not provide 12, but rather I want to use 12 in running my design. So if you still want to stick to it by using the 16, you're still open. So we can use 12, clicking on 13, and you know click on this, and after this, don't touch any other thing here. We can go here and take calculate. It's calculate based on the parameter which we've given here. We click on calculate. So you can see it's giving us on the health, on the shorter span is 170, and the longest span is giving us 180. So 180, millimeter. So I want my footing to be a square one. So making it a square one is going to make it 180, 800 millimeter. These are all in millimeter. 800 millimeter, having a square footing, and you're going to check all the necessary information if they are all okay. You see, they are all okay. You're going to check all the shear face of the column, in various direction. Go to check they are all okay. You see both direction, you go to check. So after that, you click OK. You're going to see these are the spacing provided. You want to edit, you do, but I don't want to do so. I just click. I don't want to edit any properties because they are all satisfied and okay. So we click OK, and you click OK, and you wait a while, depending on the software you're using, the graphics of the software, you can see showing you the footing. So we do the same to all. You click, you right click, you pick on the pad. At this level, the second time you're doing it, and furthermore, as you're doing it, you see that the parameter we input is still there. So you don't need to input it the second time. What you just need to do is to click on calculate. So it's going to give you say, okay, you need a square. If you need your rectangular, you can still make it your rectangular, but I just want my footing to be squared. So I click on the square footing because I want the footing to be squared, and I click OK, and I click OK, and here, wait a while, you can see you can continue the rest, doing the same design. No need to change. You click, you check, is also squared. So you said OK and OK. So you do the same to all. So that is how you continue doing the slab. Sorry. So that is how you continue adding the footing to all of them. And let's look at this point. Now you can see how close this column are. If I try inserting my footing here, look at what will happen. I click on it, I right click, I click on insert pad, I calculate, you can see, and I'm going to say, okay, I need a square footing. And I said, okay, and okay. Wait a while, you can see it's very, very close. And I decide to add the next one. I decide to insert the next one. It's calculating with 1 meter, okay? You can see this overlapping. This is not good on the structure. When you see something like this overlapping, it is better for you to design it as a combined footing. So for you to do that, you have to erase them. You have to erase them. Then you're going to click, drag. What do I mean? You right click, you drag, highlight all of them. Sorry. You're going to click, press your control, and click the other one, and you right click, and it says combine selected column and walls shear foundation. So you click on this, and you said yes, it's now as combined as one. So you right click, and you insert what? You insert this. You don't remove it. If you want to remove it, you can still remove it. But we insert the part, it's going to give us a calculation. With the same data, we're going to say calculate. So it's going to calculate for us. And you can see what we have. This is horizontal one. If we click on square, let's see what happens. You can see the square given to us. So you see, there's one thing with this software. When you have a combined footing, this is how it always turn it to be. It turn it to have a rectangular, you know, a rectangular column instead of giving us a double column. I think this software, they should model maybe the next version they're going to bring out maybe from 2024. I think they're going to work on this, please. But for the time being, it's still good. It's just that the detail will show us this. So when you're doing your detailing, you just have to put the columns at the right position. That's just it. But the analysis are intact, they are all perfect and okay. So we click OK and it says OK. So you can see let's combine footing. And secondly, here you can see we have another one and this other one is close to it. So I click on this and I insert my footing. If I'm inserting my footing with the same data and I said, square because I have 1, 8, and 9. So in doing this, I said okay and then okay. Wait, you can see we are having something similar. So there's another method I can use this if I don't want to make this, if I don't want to combine it, I can also go back, right click, take the properties, go back to the calculation sheet. What do I need to do? I will untick this. Then I have to push the arrow. I'm going to click on the arrow to make it move. I'm going to increase this arrow, that in this direction, you see, to make it a little bit, you know, horizontal so that they're not going to, clash, they're not going to overlap. So in doing this, I'm okay with this size because I always want it to be at a whole number. So I'll say okay and okay. So you can see it splitting apart. So you can still do this if you have a close dimension. So with this, you can see that we've achieved our foundation design. If we go back to our 3D, you can see what we have. That this is what we've achieved. You see, this is what we've achieved so far. Beautiful model. Right now, we have succeeded in achieving a model of two-floor building, two-story residential building. If you like what you're seeing, I would like you to subscribe, share, and comment. If you have a better way, an advanced way of doing it, you can still comment on the comment section and it will be helpful.